Okay, let's get going. So, we wrote, we got on a little tangent, wrote some other little pieces of code yesterday. And we're going to use one of those pieces of code to figure out what the problem with our current code is. So we're going to get our build script back open here. And see where it crashes. And then we're going to and also this is wrong now. Let's rename this. Hold on. This is PAINT5D GLSL Okay, yeah, so that's kind of what we're doing here. Let me kind of move this around a bit. Hold on, make sure this all looks good. Oh boy, that's crazy. I just want to... I'm amused. I just want to make this look a little bit better, because I know this little thing right here isn't quite aligned. Can we get it a little bit more adjusted here? Move it down one more. Well, that's saying that it's not. Oh, I see it. Looks like this rectangle has a lot of anti-aliasing. Is that why this... Alright, I guess that's good enough. So, also, let's change this for a second. So, let's go back to the normal URL. That was yesterday. That's really long. Can we not do that? Yeah, let's just do it. Let's put that there. Okay, anyways. Let's go back up here. Let's put this back up where it belongs. Okay, we'll choose a color. Maybe bit packing us wrong, right? And that's where we got. And we see, like, this value is compared to these two values, and this value doesn't match. And we got this value by smashing together all the bits from individual git commands, and everything looks inverted. So what we're going to do is, if we compare the binary, we might be able to derive some type of interesting pattern between this variable and this variable, and see where we went wrong with the bit packing, and see where the mistake is. So let's open up the folder that has that binary printf stuff, and let's actually put that somewhere. So in our R drive, we got a git repos, we got kanji coder somewhere around here, and then we have this binary print. We're going to steal some of the code from here. So we're just going to open this up, and there's only really one thing we need, I believe. We need this binary printf, and I don't think we need any of this other stuff. Now, we don't need any of this other stuff, we just need this binary printf command. We might want to rework it to our needs. So this is what we want. Copy that. And then within the code here, we want to put it somewhere where it makes sense. So we got, like, OK status, info status, helper functions, generic. I would say that it is really a helper functions, but it's more like logging, I would say. So we're gonna go put it right here. I'm just gonna call it helper function binary print. I know it's like, you know, one function, one section. It's like, why am I doing it that way? But I think it makes the most sense here. Right? As long as we know what we're doing when we insert these, we don't have a problem, right? Right, like it is like, to know where everything has been inserted, all these different sections, it's pretty much unmanageable at this point when you have like 8,000 lines of code here. But when you first insert the section, you can, as long as the first time you insert the section, you make a logical choice about where it's supposed to be, it's not too big of a deal that we've kind of like lost track where all the different sections are, right? Because we put this up somewhere where we don't have to use a for declaration to call it, and we put it by, you know, this other helper functions thing. Now, do you want to call it like helper functions and then just say binary print? Do you think that would be a little bit better? Because then we can, then they have the same kind of like similar tag, right? It's helper functions binary print. Yeah, I don't know. Because then if we take this and go Control F, we can go helper functions generic, helper functions conversion, and then also, didn't expect to be here. Oh, helper functions for UnitTest. Geez, there's so much stuff in here. Yeah, so that's actually, I like that. So we know this kind of already works, but we want to rename it and just make a note of where it's taken from, right? So we'll make a note of where this was cut and pasted from. So at vid iid 0091, and the time is 16, and we'll call that, I don't know, we'll call it 50. Okay, copied from, or actually it's a copy of, and do we want to also keep the library name of, like, where that was copied from? Yeah, let's do that. Why not? So let's go in here and let's go to www.github.com. Let's go to GitHub, and I'm gonna guess we are in. So we go to Conj Coder, and there was the binary print thingy we did. So binprint says shell. All my code says shell because I use almost an even amount of bash and C. Let's take this and just say, hey, that's where this was taken from, right? So put that in there, and now we have a little reference of what this was taken from. We're gonna rename it, right? So we're gonna say that this is AAC 2020 PAINT5D, right? So it's gonna be a private namespace for binary printing. And once we're at here, I do not really care about the decimal number and the hex number, right? So the nice thing about being able to cut and paste this and not make it a generic utility is I can edit it to my heart's content and modify it as how I see fit for the current situation, right? This looks kind of stupid. So let's put that over here. I kind of see why it was over there, because it was lined up with these printfs, right? So let's just remove that. And is there anything else I need to do? So there's a U32 number, and int32s, are they still in here? Yep, they're still in here. Yeah, so here's my binary printf, and then we're going to go over to, let's remove this stamp here. Maybe bit packing code is wrong. Yeah, so here we're going to just go binary printf, and the first thing I realize here is that it might be helpful to have this function also have a string for what it is we're printing off, right? So, so binary of, right? So taking like little identifier string, right? So using it kind of like a normal printf, where we do this, right? I think would make some sense. Which would require us to change things around here. So, let's take... We know these two are already correct. So let's just take two of them, right? So here's, right, because these two are already the same. So we only need to, these two right here are already the same. We don't have to print both of those off, but let's print off this and that. And let's edit the signature here. So we're going to do a string first. So we're going to say, like, const char pointer. Let's actually do chr pointer. Does it need to be const char? Probably should be. And then down here we'll put, oh, right there. We'll just call it txt. And define chr. Do you have a define for chr? No, we don't. How about we make one? So, over here, let's look at our shortcuts. And let's, this is obviously, let's see. We're gonna do something like define chr, define chr, and define chr. And if we do that, we're just gonna say that you know, define chr is gonna be const char. Now the problem with this is my shortcuts do not like this here, so as a quick little hack to get this just working rather than putting it in its own file, we're going to do the Unicode for a hashtag, or a pound symbol, or octothorpe. It's not really a pound symbol, because that's a weird thing from it sharing the key with the British pound. A hashtag is relatively new, so I'm pretty sure if we want to be really correct about it, technically this is an octothorpe, right? I'm pretty sure. Anyways, let's just throw that in there so we have it for reference next time. And might as well do an undef as well. So undef chr, undef chr, undef chr. And then right here we're going to do an undef space and space. And then, once again, this is not going to work because it has a little hashtag. And it's not that the hashtag is a comment character, it's just that it just does... It's an AutoHotkey thing that AutoHotkey just does not like trying to paste that character. It just gets interpreted as like a command or something, and weird things happen. So U plus 0023. Okay, cool. So let's put this back on my other monitor. I just wanted you to see what I was doing, so you're not like seeing me just type off screen for a whole bunch of time. Okay, so now we got this number. Number is still the same thing, and then we got this text. And what we want to do is we just want to say, at the very beginning of the function, we just want to, like, I don't know, printf and maybe %x, %s, and then just the text, right? So that is kind of weird. If we do it that way, we don't really need to do it that way. We can just do... That's a convoluted way of saying this, right? I'm kind of interested, though. let's just give that a shot anyways, because now I'm kind of interested. So printf, and then after we've printed f, we're not going to do a new line. And so this is going to be just jammed right up against there, but we can add some extra spaces, right? So we can take advantage of this and say, hey, you're going to put, like, I don't know, 4 spaces maybe, right? Okay, yeah, so let's give that a shot and see if we can, oh, hold up. Define char const char. Then down here, we're going to have to undef chr for character. Okay, cool. So now that we have this, let's go back to our build script. Let's give this a run and see if we didn't make any syntax mistakes. U32num. Some type of mistake, and it's because this comma is in the wrong place. Okay. Okay, cool. So we got this little binary printout, and say the bit packing is quite different. So what I'm seeing that's kind of interesting here. So this is nice. This is nice. I am very glad that I wrote this function, because if we zoom in here, we zoom in on this console. I don't think we can zoom in like this because then you can't see it. Oh, you can see it. Okay, cool. So if we zoom in and we look at right down here, you can see that these nibbles of what we're bit packing seem to, oh, nope, not quite. These nibbles are different. Okay. So what could be causing this? Well, how far do some of the bits get? The bits only get this far. There's never any bits over on this side, is something I'm noticing here. Now, that could change depending on if we use, like, different values, so we might want to consider using different values. But okay, so we're on to something, I think. So the next question is, I know when I wrote a lot of these tests, I kind of like stubbed them in. And so there's a potential that the original test code for this bitpack get, or the bitpack put, is not quite good enough. Let's look at bitpack get and see if it makes sense. But I am notoriously good at screwing up bit shifting, so that's also a thing that could have been done. So if we look at the tile value we got, we're going to mask it with this binary, which should be 2 bits. Yep. And after we've masked it, we're going to shift it over by the offset dex, multiplied by 2. That looks good. And then we're going to OR it with whatever we're building up here. And we erase it before we start building it up, so that's okay. And why do we have a 1 and a 2 here? So we got this one, and then we got this one. One obviously has a mask. Actually, that would be kind of important to look at both of those. And make sure that they're not different in any way, right? Because we did the bit shifting for this in 2 different ways. I don't think it is. I think, but we should probably inspect that, right? So, well, actually, no. It says right here, you know, if RBP not right. It already has that, so that's not. Well, if we're gonna get this crazy, we might as well put both duplicates, right? So, if that's the way we're gonna roll, then, right. We'll just put it all. We'll just put it all out there. So, okay, right. So, The first two, right, so these first two are the incorrect ones, they're identical, and the second two, they're identical. And these are the proper ones, right? Or what we think is proper, so we're not sure anymore. All bets are kind of off right now. So we're going to see if we have any tests for bitpack get. Maybe we did not properly test this, maybe not write enough tests. So it would be nice to just see... Okay, so here's the function. And where are we here? Is this a test? Nope, not a test. So here's some stuff. What test is this now? Is this a test for the bitpacking? Yes, this is bitpack get. I would say that's a pretty good series of tests, right? Where it's like, here's a big ass table. Testing all these things, and we know the tests already pass. So I'm kind of fairly certain that this is... that this probably works. But you never know. This just might not work, right? Maybe there's some type of mistake here. I mean, we're not testing it with everything, right? We're testing it with a lot of values. But we are not testing it with everything. But we did a pretty thorough test, though. So let's just take this here, put a little breakpoint there, and go back to where we were originally. So maybe the bitpacking code is wrong, right? So that's what we think. And we're using bitpack get. And if we look at the bitpacking, right, we're expecting that we're going to get in this order, right? So the lower values that we get for this need to be shifted over the least amount. And that's what we have here, right? So if we start at 0, the 0th, then we're going to shift over 0, and then when we're at 1, we're going to shift over 1 times 2. We're at 2, we're going to shift over 2 times 2, at 3, 3 times 2, etc., right? As seen here. And for some reason, the bitpacking just says, nope, you're wrong. And I don't know why that is. I am pretty good at getting bitpacking wrong, so it's like maybe we should make sure it's not the bitpacking. So when we get the value, where are we? Are we in a loop? Yeah, we're going through the X's and the Y's in the correct order. And we are red, green, blue, and alpha. Global component index, so we're kind of like packing this into the CPU pixels. PAINT5D CPU pixels. Looping through every single pixel. To get this U32 variable, we're shifting it all together. And then we're going to check to see that if we can get the same components out. We're just checking our logic here with our bit shifting, because, you know, we're pretty bad at bit shifting. We get that wrong a lot. So we're taking this global component index and we're converting it into... we're taking the XY and converting that into a global component index, right? So index to XY to index formula here, and then multiply by 4 to get the red component of the pixel, and then offsetting correctly here. So, and then global.x, global.y is px, and so we're going to try to do a texel fetch on the same memory that we just inputted stuff here, right? And so this U32 got here should equal to U32 var, and U32 var is right over here, right? That's all well and good, but one of the problems I'm seeing is if we try to shift this back out, do we run into some type of mistake, right? So let's double check U32 got for a second. I'm gonna double check U32 got. I really don't know what to do, so we're just going to try some things and see what we can do, and hopefully eventually find the problem. So I'm just gonna do dub for double check, and if we take all of these things that we packed in here, well, hold on. Does this bit pack get? That's kind of what this is for. That's... So I don't think this is gonna fail. It's just unpacking things. Right, so 24, 16, and 8, and 0. But right now, we're really at a loss for what's going wrong, so we need to do whatever we can to get this working. So we kind of OR all of these together. We should... let's actually remove the parentheses here, because maybe, you know, maybe parentheses do something, right? And we forgot parentheses somewhere. So let's write it like this rather than like this, right? Usually we'd write it like this to be a little bit more careful, but let's actually just write it like this and see what happens. Dub chk equals double check. And then, this got var double check is not equal to U32 var. Error. I don't know, my 2021 0115 0623 PM. Yeah. So I really doubt that's going to fail us. But if all of the obvious stuff there's no obvious mistake here, right? So we gotta test things that might seem kind of stupid just because we don't know what's going on. So maybe the bit packing code is wrong 2021. So the first thing we could do is we could try a simpler test where we try to look at every single yeah, I don't know. It's looking to me like the bitpack get needs... It looks to me like bitpack get just needs more attention here. Because testing bitpack get, we didn't use the texel put command. We just manually put it there, and it's failing us. So if we go back to here and look at this bitpack get function, so the global component, the offset dex, the tile value. So all these tests are they are doing it. These tests are very much in an encapsulated format where we're making an assumption of... We'll hold on this here for a second. So this U32 var. So these tests would seem to tell me that I'm already trying some type of manual packing thing, and it's working here. Alright, so this got val. Hold up here. This tile value here. Guys, so we're like individually merging it in there. So I think that our bit packing isn't quite working. I think that this is testing one data point at a time, and it works on a one data point at a time basis, but then there's some type of collision with some other data, maybe? Yeah, so I think bitpack get is somewhat wrong. So let's yeah, so I think it's the bitpack get function that's wrong here. And So what do we want to do for that? Do we want to create, this is testing polyfill texel fetch. So if we're going to do that, we might as well... do we want to make another series of tests for bitpack get and kind of remake what we already did there? Okay. Oh, we're already doing it here, huh? So let's look at this test function and see kind of how it's written. So looping through everything and doing all this craziness. And when we run this command, when we run the put get, does that automatically work? Does this all work? Does this all pass? So if we change the order of this really quick, right? So if we change the order of this, do you get this to fail? Let's run that again and see what's happening. So it's saying the problem is the transcription here. Right, that was kind of like our guess. We're pretty sure the problem was the transcription, because we were making the assumption that this command worked, right? So, we're gonna put this back here like this, because I think it might be the bit packing. And... I don't know what we'll do here. EV, there's so much stuff going on here. I don't know what a good namespace for this. Do we want to, like, just keep this kind of same namespace here? But then it just gets really long, right? I guess technically this is the common namespace. Manual... I don't know, poke and prod, bitpack get, so, I don't know what to call it. But let's just make a note here that, So at vid IID 0091, and the time is 9:58. So failure of polyfill textile fetch leads me to believe that bitpack get might actually be wrong. Let's do tests that are aware of the internal bit structure, bit layout. So the previous tests for the bit packing that we did were kind of like these encapsulated tests that just said put the value, get the value, put the value, get the value. But we didn't have anything that says, hey, you know, bit shift these things into this place and then get the values, right? And we know what the format of the internal data is, so, you know, just modify these bits and then get the value, right? So we have tests that do a get the value, then put the value, but we don't have tests that do this crazy bit shifting on the data structure and then get the value, right? We don't have something like that, so we're going to make something that's aware of the internal bit layout used so that we can hopefully find what's going on here, because I don't know. So we're going to take this poke and prod function, and we're just going to go, it's still in the same order, right, because this is the polyfill textile fetch, whatever. So void. Okay, so this is where we'll write the test, and we're going to kind of steal from here somehow. So it seems the textile fetch worked all right, but then when you use bitpack get, that is where it broke down. Okay. So bitpack get is where things break down, so let's copy that. And we want to put different 2-bit values in location and just see what happens. So, now when we're putting stuff in place, are we completely overwriting? Yeah, this is a complete overwrite here. Okay. Okay. So CPU picks, let's just, you know, define CPU picks, and yeah, let's just define it like that, and then, you know, undef CPU picks. I actually just feel like, you know what, I feel like just doing this. Here's the CPU pixels. Right. And this global component, I'm just gonna call it GC. I'm just tired of long variable names right today, so we'll call it glocom for GC. This is osdex, right? So osdex, and this is the tile value over here. Okay. So let's remove some of the casting. I mean, that could be one of the reasons things are going wrong, though. But we'll find out, right? So, so for bitpack get, how does that work? So if we look at our notes, we have a note file that will already say this. So if we do pixname notes, or not PAINT5D notes. Yeah, so we have it right here, bitpacking. Right, so they're all U08 values, which we see in the comments here. So U08 GC for the global component, U08 AC for the offset dex, or AD, offset dex. And TV is tile value. Let's make a section called declare vars, right? We'll try to make this kind of nice. And so what we want to do is we want to do something where, let's say the global component index equals 0, right? Start off with something really easy. Well, actually, that's not correct. That will never work, right? That's not... No, that's okay. That's okay. We can do 0. And... if the offset dex is equal to so if this is the global component index and the offset dex is here and the tile value is like 3, right, which is binary. This is bin, right, this is binary 1, 1, right, so it's the largest tile value we can have. If we use all of that, how would we pack it into here so that we can get it back out, right? So, I'm going to rename these. I'm going to say that, do I need to rename them? We don't need to rename them, but we do need to say that, for the tile value, there's going to be a put tile value, or a packed tile value, and there's also going to be a got tile value. And this is... right. So this over here will be our packed value that we're going to pack using these as our locations. And then over here, we're actually going to get it, right? So this will be our got tile value. And in order to pack it, we're going to say that first we know that we have know that when we pack a value, there's potentially like all of this that could be going on here, right? However, okay, hold on here. If we kind of pack it into each one of these bytes individually without reading, then we're going to overwrite things, and that's going to be improper, isn't it? So are we perhaps doing that improperly over here? So if we see this, we have so this red, green, blue, and whatnot. We're packing them. And so to store red, green, and blue, we're storing like a whole pixel worth of value here. Why are we storing a whole pixel worth of value? Okay, right, so we're generating red, green, and blue, right? So we're generating some gibberish to kind of pack into here. Okay, fine. So we pack it in there, and eventually we pack it back in here. That's fine. And then this offset dex here, we're going through it, and what are we trying to rebuild? We're trying to rebuild, oh, got ya. So we're trying to rebuild the original pixel, right? So we shove some arbitrary pixels in there, and we're like, well, if we shove arbitrary pixels, well, the problem is that no, that could make sense. But is the U32 variable an example of all these smashed together? And yes, it is. Okay, so I kind of see what I'm doing here. And that's failing. Okay. So I was just making sure. So global component index. So rather than we're gonna do kind of some very manual-ish kind of test here where we're expecting that if this is all the way at 0, as we're expecting something like this, and we're expecting this to be shifted over by the offset dex. But this should be shifted over by 0 because offset dex is 0, right? So this is kind of what we're expecting. Right, so no actual shifting, it's just kind of assigned here. And then we don't really care, you know, so right here is a shouldn't matter, right? So So we're going to try like this manual test here. We're going to define shouldn't matter as 0 here. And we'll change it around depending on what we can do to make this break. Because I don't know, but I think we should give it a shot. Okay, so bitpack get pix, GC, AD. So, if got error So we'll use this right here to mean manual, pack, and unpack test, right? That's what this is going to stand for right here. Yeah, let's give that a shot, and we'll have to do some trickier things, right? Like try over here, and over here. So right now this is right here. We'll want to move it into some other places as well, but this is a good start for now, and see what we can derive. Define shouldn't matter. Oh, we gotta add a space here. And then undef pix needs to be like this. Now, if this test actually fails, it'll be easier on us, right? If it just maybe the packing code is wrong, so we're still not failing here. The next thing is let's just make sure that this is actually executing. So I'm going to set that equal to each other. Okay, so it is actually executing. So let's make a note of what's going on here, right? Let's put a breakpoint here. I suspect so this is what's going on here. Pack the tile value directly into the pixel byte array here and confirm we can get it back out with the getter method. Okay, so let's update this for a second. So 110, and we'll say that that's 11010. Good. So yeah, I'm suspecting that this test function is not working properly, or it's not being thoroughly tested enough. And so we're going to try to pack the tile value directly into the pixel, like this, and see if we can still get the value, right? So we change this to shouldn't matter. So we should also try shouldn't matter could be something like 0x ff, right? That's the maximum we could set in here. And that should not change the result of the test. But we want to throw something in there that'll kind of cause some interference if our retrieval function isn't quite correct, right? So let's give that a shot. And nope, it's still passing, so that's good. And what we're going to do is we're going to take all this code here, we're just going to copy paste it and write one more function. And we're going to get rid of this commentary, right? And we're just going to move everything. We're going to just slide everything over, right? So, alright, I'm going to put this over here. And if we put this over here, we got to think about, well, where are we now, right? So the value is the offset dex has changed, right? So everything else is the same, but the offset dex has changed. If you look at our diagram for how we were bit packing, right? Here's the first 4 bits, and then here's the next 4 bits. So this starts at 4, right? So if we are just packing, if we're just shifting over 0, we're starting at the base, which means that we're over here. Like this is the bit we're looking at here, right? So if that's the bit we're looking at, then to get that correct, the offset dex, we just do a 0, 1, 2, 3, and 4. We'll make a note of this. This one's changed. Right, so when we're looking at what has changed from this test here and this test here, the only thing that we're really changing is this offset dex. We're going to pack the same exact tile value, and then we're also changing this as well, right? So we moved this up as well. So we could just call it at delta. Might make more sense to call it at delta, so we know that it is different. Sure. So we're going to expect to still be able to get the same value, right? So the packed tile value is still 3, but we're kind of like moving over here to do it. Now, if that's how we want to play this, then we should probably use another location, another global component index, or we should zero out everything that was used before, right? So let's zero everything out. Let's zero out the previous. Well, actually, no, we don't have to zero it out because we're setting everything to shouldn't matter here. So I mean, that's good enough, right? Yeah, let's give that a shot and see if this fails. And I don't know if it is. I don't think it is. I'm just kind of, this sucks. Yeah, I don't think it's going to fail, but I'm hoping it fails, because the quicker I can get this to fail. So, that's not failing us. Well, now the other thing is that this shouldn't matter is kind of like these all ones, and we're packing a value that's all ones. So does that really create the kind of collisions that we're expecting? Because I don't think it is. So let's set shouldn't matter to 0 really quick and see if that changes anything. Define shouldn't matter. So shouldn't matter is redefined because we have to undef it over here. Okay, so let's try that out and see what we can get going here. Nope, it's still failing in that other function. It needs to be a value under 255, so I don't know, 222. Alright, let's just try with some other values and see what we can do. Okay, so let's try some more stuff, right? So let's try another test. Let's just paste all this. This will be test number 3. And for this, we will take this component location and we'll just change it to something like, I don't know, 64 times 7, right? So 64 times a prime number. And the reason I'm going to use 64 is I noticed that on the x, actually, times 4 times 7. And that should be within range, right? So 64 times 64, or 64, 128, 256 times 7. Yeah, that should still be in bounds. But we're going to add a prime number. We're going to make sure it's over 64, because I noticed that some of my tests were failing once the x value got over 64. So this will make sure that the x value is over 64, and see if that affects anything. Now, this thing here, the offset dex, that doesn't actually have to change if we just do this, like that. Let's change this to, like, 23. And let's give this a run. Oh, got ya. Oh, hold up here. The global component index. I already see the mistake. So, the global component index needs to be used to access a value on a 512 by 512 bitmap, right? Well, if we look at the component index for something that's 512 by 512, well, a component could be, there's 512 times 512 pixels. Okay, so we're already way over 255, and then we got to multiply that by 4, and now we got 1 million, right? So this can't even be contained by a 16-bit integer, right? Like if we go into hex here and we go, 7 and FFF, right? That's not a million. That's the signed version of a 16-bit integer. If we try, let's try how do we clear things? Where's my clear button? Clear button? Okay, so if we try something like just F's, right? So 1, 2, 3, 4. That's nowhere near 1,000,000 either, right? So the global component indexes here should be like everything else, but this global component index absolutely must be 32 bits. And we have totally botched that. And of course it's not going to work if, yeah, of course that's not going to work. So yeah, once again, our values being out of range is getting us in trouble again. So, but now we've kind of found a very big glaring problem here. And we're going to have to go fix it, aren't we? So the first thing is, anywhere we see this thing, this needs to be, we could probably do it int32, right? So, int32 maximum value. Yeah, so much more than 1,000,000, right? So here's our millions places, and here's our billions. So yeah, we're fine. Yeah, this is the signed version. Yeah, so we're fine if we use a signed integer here. So wherever we see this signed integer, we want to use int32 here. So int32 and int32. And this is just the commentary. This doesn't actually fix it, does it? So int32. So in bitpack get, we're just doing this improperly. So that's kind of scary because we could have a lot of mistakes in other places as well. So before we fix this up, we're going to have to go into our PAINT5D data file, and where we turned off those tests, we're going to have to turn them back on. So, our unreliable kill switch for turning off the test, we're going to deactivate that. Because we're going to need to rerun these tests. Because we're not, right, we already know that we're not using the correct values for bitpack get. So, let's make a note here. I don't know we're gonna do it. Let's just make a note here. So make a note of what this needs to be. We'll make a temporary marker of what video we were on when we did this. And the time is 1 hour, 23 minutes, and 50 seconds. So yeah. So yeah, we need to make sure that the bitpack get function is using int32 for the global index location, which we're not. So we're gonna have to fix that. And that also means that this global component index here, this needs to be at int32 right here. So this needs to be at int32. The offset dex is fine. It's just those other things are not fine. So let's look at our PAINT5D notes here. And we can see that this glowcom in our notes needs to be at int32. This glowcom here needs to be at int32. How the heck did we get any of our tests to properly pass? I don't know. That kind of sucks that we've written all these tests, we think that things work, and then we write more tests later and realize, hey, this actually doesn't work. So yeah, it almost seems like you can never have enough tests. So let's run this, right? So we just want to run the long version of our test code just to have a quick sanity check, make sure that that the original tests are not broken, right? Make sure the original tests are not broken. And if the original tests are not broken, then we can feel a little bit safer about starting to edit the signature, right? Because we're going to edit the signature of a function that we already wrote. And that is maybe a bit packing code is wrong. Okay, so it's still failing at the same place, so that's good. Took a lot longer to get there though. So yeah, let's take the signature of bitpack get, bitpack put. They actually both need to change their signatures. So let's go look at get, and let's go scroll all the way up, right, and then search back down. So this global component. So this global component here needs to be at int32, right? So right here, this needs to be at int32. Bitpack get. And we need to look at where it's being used. So we're doing this thing here. That's cool. Where else are we using it? The global component. Okay, that makes sense. Global component plus whatever the heck to access. Okay, cool. So that looks good. That's all we had to do. Because we're not using it anywhere else. Okay, so let's look at the bitpack put, right? So let's look at bitpack put. And let's scroll back up again, because we put before we get, so it was actually before. So bitpack put global component is right here, but remember, it needs to be at int32, right? Global component. And if we look at this, all the logic will probably be very similar. There's probably just a few minor differences. But anywhere we're using it, we just want to check for any overflow. So this arrayDex needs to be checked. So arrayDex, see, we're smart enough here. We're smart enough here that arrayDex is, in fact, int32, right? Because where we use glowcom and we add this together to get the arrayDex, that needs to be that way. Here, we don't have to worry about overflow. Okay, so that looks good. Let's look at this again. So the glow arrayDex is commented out here, but is it int32? It's still int32, even though it's commented out. So if we commented it back in, it would still be correct code. Okay, cool. So one last thing we're going to do, just because we're paranoid here, is we're going to make sure that we have two of these, right? So if I highlight this, actually let's highlight this as orange. If I highlight this, then the put function should also kind of highlight, yeah? There you go, bitpack put. Excellent. So that is definitely a mistake that would cause our code to crash. So I'm kind of disappointed that it's in some old code that we already wrote a whole bunch of tests for. But yeah, oh well, you know. Let's just give it a run. And let's see if we're lucky, everything's just gonna pass now, right? If we're lucky. Or if we're actually, I just don't, if it doesn't fail, if it gets past where it's currently failing, I'll be kind of happy. If it fails in the exact same place, I'm gonna be kind of eh. But I mean, that's a big difference, right? Okay, so still failing us, huh? The other thing, though, however, is that the tests we wrote are probably not correct now. And why I say that is because I know we had some cast, like 8-bit integers and whatnot, so if we look at this code here, and we look at where we're using the functions for the bitpack get here, this textile fetch probably uses that bitpack get command. So yeah, let's look at the polyfill texel fetch here, because I bet it's improper. So if we look at the polyfill for the texel fetch polyfill again, I bet that is now broken, right? We thought it wasn't broken, or not the texel fetch. It is this global component might be improper. So the global dex, the global component, we have the right signs, we have the right sizes here. But how about this? Is the global component here the correct size? int32. What about this? This global, what about this? Do we screw that up? Is it even in this file? I believe it's in this file. Or is it not? Is it over here? Oh, it's over here. So int32x, int32y, that's enough addressing space. Yeah. Yeah, that's enough addressing space there. But I'm kind of, you know, we made some fixes, so I'm kind of like thinking that the mistake is now with this logic somehow. Yeah, right here, right? It's a bitpack get. We're reconstructing it, but we take the global component index and we are downcasting it, right? Because that's what the signature originally wanted, so I downcasted it, but that is completely improper. So if we so I'm just going to make a note that this was fixed. This is an int32. So this is fixed. You know, and we can do @vid IID 0091. And the time for this fix is 1 hour, 33 minutes, and we'll call it 25 seconds. Yeah, so at this point in time, we just found the fix for why this reconstruction of the, right, we want to reconstruct the pixel by using bitpack get 15 times, and fetching each individual tile value, and then packing it together, and for some reason that wasn't working, and it was because this global component was being casted to 8 bits, when it definitely needs to be at least 32 bits. Signed or unsigned work fine. Since we have enough room, we decided to use signed, just because signed values are a little bit less error-prone than unsigned, so if you have enough space where you can make it a signed value, then do so. So I think that will actually make it so that this bitpacking code will no longer fail us. So let's give that a shot and see if we found the problem. And I did not feel like doing any work today, so if I actually solve this problem, then I'm going to be happy. Right? Because it's not even 2 hours, and I already solved kind of a big deal. And then maybe we could take a break and do kind of another interesting, short kind of video on So now we have problem is the transcription. Okay, so now the maybe bit packing code is wrong. That's no longer getting triggered. It's now problem is the transcription. And if we look for where that is, so if I take this and highlight it, really quick, and then I look for a problem is the transcription, I'm pretty sure it's somewhere down here somewhere. Let's just, original code, problem is the transcription right here. So this should be unique. Okay. So that's interesting. So one of the things, though, is if we look at the test of the original code here, we see that the global component thing, we've made this mistake more times, right? The global component here, in this area where we're failing, it is being downcasted, and that is improper. So there is the possibility that we need to look in a lot of places. So I'm just gonna make a note here. Look for all glowcom and make sure it is int32. So we need to really look for all these things that say glowcom and just make sure that they're int32s. So it's already int32 here. But for readability, if we want some readability, we might want to just say this, you know, int32, right? And I'm going to guess that might actually solve this code and make that work. However, I am a little bit concerned about possibly the texel fetch we got wrong. Well, this global coordinate here, we already know that the components are 32-bit integers. How about this glowdex and glowcom? They're already int32s here, so that's good. Are we using any functions here? No, we're manually packing, so I don't have to worry about that. So, yeah, let's give that a run. I bet this might make the test pass. And we're gonna start, I don't know if I want to start putting the size of the types in the variable names that I use, because now I see that it kind of matters. Okay, cool. Excellent. Nice. Awesome. So we're running again. All of our tests ran. And we just had some hiccups where it seemed that we found a bug in our original code. Oh, but we have some more tests to do. So hold on. So at that we do not actually have more tests to do. And I'll tell you why. Because this is the main function we're testing. And as long as we can get this function to pass, right, and it actually works, it doesn't fail, right? Because this test was actually failing us when we first wrote it, and that's why we had to backtrack and test the other sub-functions, right? So the analogy was this function here is the chain, and if the test for the chain fails, then we have to individually test each link to figure out what's causing the underlying problem. But because the chain right now is passing all of its tests, we don't have to go in to all of these different things and test them out. So what we're going to do is make a note of that, right? So, and the time is 1 hour and let's say 40 minutes, because it's going to be that once we get here. So yeah, I'm going to say that again one more time for the camera, that we do not have to write any test code for here, because these are like the sublinks of a chain, where this function here is the chain that we're testing, and we want to make sure that this function works. And these functions here, are sub-functions used by this function. But as long as this function works, we don't need to drill into all of the other functions and test them out, right? By inheritance, I guess, I don't know the best word, by inheritance, if this function works, all of its children functions must also work, right? So we're not going to write any tests for this. No tests needed because right? Because so we're going to kind of make this look nice. And then I will probably state for the camera one more time what's going on here, after I've kind of like cut and pasted this. Yeah, so once again, we do not have to write the test code in here. We don't have to write test code in here. And we don't have to write test code in here. We just don't have to, because this thing is already working. This transcription already works. Therefore, there's no reason to dig in and individually test all the little components, as far as I'm concerned, right? I've written a lot of tests. It's not like I don't think that I'm being unjust here, because if you look at this, what is all this? What is all this for a second? What is this? Can we find the unit test section? Let's just go unit test section for a second. Unit test section. I thought we called it unit test section. I know we did that in some other code. So yeah, unit test section is right here. Notice that we are not even halfway through the file, right? So more than half of my code, right, starting from here and going all the way down here, right, all the way down there, it's all unit test code, right? More than half of my code is unit test code. So I think I am justified in saying, yeah, I don't need to write that test code. Part of me is kind of paranoid, though. I am saying maybe I should. God. Yeah, there is part of me that's like, has this irrational fear that I need to write it. Let's actually look at it for a second and see where that code is. God, we're like all over the place. Hold on. F0091. Let's just look for... Yeah, so we're saying we don't need to write this. Tile exponent to maximum coordinate. Yeah, I think that writing this code here, the logical part of me says that it's just out of a rational... To write this code would just be out of an irrational fear, or an emotional drive to write the code rather than being logical. I think that any desire I have to write this function, any inclination, I think is actually not logical. It's just that I'm obsessed with kind of like going overkill in writing these tests. Hey, so I see you popped in here. So we just got some unit test code running, and these functions here, we're not going to write any test code for them because they are sub-functions used by this function here. And this is the only function I care about right now. And as long as the test for this code passes, if the test for all of this code passes by proxy, we know that these functions here are also working correctly. So a good analogy for that is saying that if we're testing a chain, right? If we're testing a chain and seeing that it can hold a load, if the test passes for the chain, we do not have to write individual tests for every single link in the chain, right? Because if the chain can do its job, then logically that means the individual links are also doing their job, right? Because a chain is only as strong as its weakest link, right? So the same thing is going on here. So we originally made all these stubs for these tests because this test was failing, and we had to figure out where that was happening. And we did actually write an extra test, so we wrote this extra test, this bit packing test, to test out, to try to find the root cause of why this function was failing, and that worked, and we found the root cause, we fixed it, we addressed the problem, and now the code is passing all of its tests. So what code am I talking about, I guess? Also here, let me drop my demos in, so I don't know who's watching me. It could just be my girlfriend. There's my demo reel of a whole bunch of fancy, shiny stuff, and a lot of that shiny stuff in that demo reel is kind of what I'm basing this engine design on, right? They are the little proof of concept prototypes that I'm going to use to create this engine. So if we look at this file on my left here, all of this code is C code that has been written specifically so that I can cut and paste it into GLSL shader code. You'll notice that this part says do not cut paste into GLSL shader code. That is because in order to get this code working as both C code and GLSL code, so GLSL code and C code are very similar, but they are not actually the same, right? GLSL is a C-based, based on C99, and so there's a lot of similarities, but they are not the same. So we want to somehow do this hackish thing where we write the code as C, so that we can test it over here on the CPU side, and then once we know the code works, we can just directly cut and paste it into our shader code and just get it to work. So this right here is a polyfill for the GLSL texel fetch command, right? So we have to emulate some of the GLSL commands in order to write this kind of C code that we're going to paste into the GLSL. So this is our texel fetch polyfill. And all it does is it looks at our CPU side allocation of pixels and fetches the pixel, right? So on the CPU side, every single pixel is stored as 4 individual bytes in a byte array. So that's why you have this 1, 2, 3, and 4 bytes per pixel, R, G, B, and A within that order. And we just glob them all together to create a UNT32 pixel value, right? To emulate how the texel fetch command would work in the GLSL. Then down here, we have the macros that are going to make this possible. So when it is GLSL code, all of these defines are going to be GLSL types. Right, PAINT5D is the name of my texture sampler in the GLSL code. Texel fetch is the actual texel fetch command, right? And then over here, instead of having texel fetch like here, we have the polyfill for P5D. It's just unused when it's on the C side, right? So this is the C code. And we might actually want to make a note here, right? So let's actually make a note that this is GLSL when running as GLSL code, right? So that's what this is. And then over here is when running as I don't know. Right here is when running as C99. Right. So that's what's going on over here. Okay, so macro, this is GLSL is not defined in here, right? So I'm also going to do something here where I say so I'm going to take this. I'm just going to make a note that, you know, if error this is not OpenGL. This is not GLSL code 2021. So, right, the idea is that this macro should never be defined. This macro should never be defined in this section here. Okay, so just... Okay, cool. So let's give that a run, right? We're just kind of polishing this up a bit. And then we have to think about, we got to look at our agenda. Unterminated if def. Okay, so obviously don't... oh, it's not an undef, it's an end if. My bad. So after we can confirm this is working, we're going to have to figure out how to... We're going to have to look at our agenda and figure out what's next. And I don't know what's next yet. We'll have to figure that out as we go. We'll probably put the kill switch back on the unit test code for this, just because this is taking too long, and I don't want it to take us forever every time we do this. So let's do a git bash here. Git status, git add dot, git commit dash am, glsl transcriptions work glsl okay. And we will we'll paste that in there. And then what we're going to do is we're going to do our push-ups, I think. Or actually, let's look at the agenda, then we'll do our push-ups. We want like 20 per hour, so we'll say 40. And, well, if we can do more than 40, we'll do more than 40. But let's look at our agenda for a second. Agenda screen. Finish P5D OGL test code. So we just did that. So we can check that off. Start building default PAINT5D shader. Yep, we got to get at that. So that will be, I think that will be the next thing we want to do. We need some other code to get the data into the shader still, but we could try to paste what we've written into the GLSL code and see if we can get that running now, and if not, figure out what we have to change in the C code to make it valid GLSL. Okay, so let's look at our push-ups thing. Okay, so we were kind of disorganized here yesterday, where we're like, so the week total, The total today is 0 right now. And we want to create like a little thing here where we keep track of the days. So exe Monday, Tuesday, and can we just delete this and then hold on. So if I do, can I copy paste this? That'd be nice. Then I'm going to rename this. Oh, they're like references, huh? Yeah, I'm gonna take some time to just organize some stuff now that I've got to a good break point. Oh, there we go. So let's take this. So this is going to be Tuesday. And we're going to create like a little spreadsheet here, because as I've been trying to keep track of this week total, I don't know if I've been doing the best job. So we need to create like a little ledger to make sure that we're doing this correctly. So Monday, this is going to be Wednesday. And I'm going to actually put it all in its own little section here. So actually, if I do this, if I put this over here, can you actually see what I'm doing? No, you can't, because it's on this screen. So I'm going to paste another duplicate. I'm going to rename this. This is Thursday. Monday, Tuesday, Wednesday. Thursday. It's going to be Friday. And rename. We're just going to keep on pasting. Paste. So Saturday is my no work day, or Sunday is my no work day. And because of that, did I say Saturday? I keep on getting those mixed up. Sunday is my no work day. No relationship to the Sabbath. It's just that's what it ended up being. maybe a connection to my culture, and just that, you know, people usually take the weekend off, and so I take 1 day on the weekend off rather than 2. So we shouldn't even be touching OBS when it's Sunday, right? And because of that, we don't need a ledger for Sunday. Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday, yeah? Okay, that's all accounted for, cool. Okay, cool. So now we got a nice little ledger here of all of the totals. And we don't know what the totals for other days were because, you know, we have this week total here. We don't know exactly what was going on here. Yeah, so let's take this. Let's just delete this. Is there anything else we have hidden here? Nope. Okay. So unlock this. So today we did a 2-hour stream. We may do more streams today, but right now 2-hour stream. And I'm gonna try to do my push-ups really quick before I don't want to cut off the stream now, or do I want to do my push-ups off stream. I guess I don't really want to waste time doing that. I think we're already done here. Let's we've organized things. That's nice. But what we will do is we'll say we'll have to just commit to what we want to do. Let's commit to 60, because if we do our 60 and then we eat our food, we'll be in some good standing to get the other 40 done. So let's change this to 60 for today. And today is Friday, right? Friday. Let's put a 60 here. And then we'll add 60 here. So 60, so that's 15. Hold on. So there's 3 left over after we add the 6. So that should be 530, right? Yeah, that should be 530. I want to make absolutely sure, so I'm just going to count on my fingers. 80, 90, 100, and then 60. Yeah. So 530. Okay, so this will be 530. Okay. And I'm going to leave it at that, and I'm going to stop the stream. I'm going to do my 60 push-ups and crunches and sit-ups, crunches, squats, dumbbells, jump on the trampoline, etc. So